Good morning, dear students. Today we'll see the next distribution, normal distribution. In this normal distribution, it will come under again continuous probability distribution, and it is defined as f of x is equal to 1 upon standard deviation. The symbol is standard deviation, that is sigma, square root of 2 pi into e raised to minus times x minus mu whole square divided by 2 standard deviation square, or variance I can say, or sigma square. So this is a function for normal distribution. By using this, we are going to simplify the problems based on this normal distribution. Here x is lying between minus infinity to plus infinity, and mu is lying between minus infinity to plus infinity. This mu stands for the mean, and the standard deviation, that is rho, is positive, is known as normal distribution. And here also both the conditions will satisfy. The function f of x will be greater than or equal to 0, a function or probability, and integration of f of x dx from minus infinity to plus infinity will be 1. So if two conditions satisfy, the given a function f of x is called what here? Probability density function. So no proof for mean, variance and standard deviation, but results are mean is given by mu, variance is given by standard deviation square, or I can say rho square, and SD stand for standard deviation, which is nothing but square root of variance, which is nothing but what here? Rho, or I can sigma, whatever symbol you can say, or else in a simple way I can say this is symbol for standard deviation. So using this, we'll see a few more basic criteria here. Now note the graph. See, the normal distribution is always in the form of bell shape. Okay, always it will be in bell shape, and the peak, this if you divide exactly, so this is the value of x, and always this will be 0. The graph of the probability function f of x is bell shaped curve, symmetric about the line x. So here line is x is equal to mu, and is called a normal probability curve. This curve what we have, this is normal probability curve, and the shape of this curve is as follows. So usually this kind of curves you have seen in your lab, while doing the CRO experiments, or whatever analytic functions problems, so examples what you have done in the lab and all you have seen, or else I can say that best example, you have seen the fluctuations of your heartbeat, or your BP and all in the screen of the device what we are going to use in the hospitals and all. So this is nothing but a bell shape, and here the equation of this curve is nothing but x is equal to mu. So the line x is equal to mu divides the total area. So this is a curve divides the total area in two parts, part 1 and part 2, okay, in equal part and into two equal part, and the area, so this area is on this complete area what I can say, this bell shape, what area is it? Complete area will be always what here? Equal to 1. So this area will be 0.5 and this area will be 0.5. so left hand side, right hand side, so if you add you will get completely 1. So the line x is equal to mu divides the total area under the curve, which is equal to 1, into two equal parts. Okay, the area to the right as well as left of the line is nothing but how much here? 0.5. So using this of the basic, I will go for a few illustrative and example which is not there for exam, just to understand I want to take that one. Now a few standard normal distribution is defined here. So here the normal z is equal to x minus mu upon standard deviation is called standard normal variate. So the given x value, to convert in terms of the normal variate, we are going to use this formula after replacing the value of x, mu and standard deviation, will get the value of z, so which is most useful in the examples in the normal distribution. And then f of z is equal to 1 upon square root of 2 pi into e raised to minus z square upon 2 is a standard normal probability density function or normal curve. So you need to remember this. And phi of z is equal to 1 upon root pi integration 0 to z e raised to minus z square upon 2 dz is represents the area under the standard normal curve 0 to z. So these are the few standard normal distribution results, and some more results while solving the examples. This will be most helpful here. So p of z greater than equal to minus infinity less than equal to infinity can be represented as integration of minus infinity to plus infinity function phi of z dz is equal to 1. Okay, then second result. So just see, so minus infinity to plus infinity means, you can refer this diagram, minus infinity to plus infinity means this complete area, and the result is 1 what we have taken. So here, so mathematically it is represented like that. So second one, p z greater than or equal to minus infinity but less than equal to 0 means this is your straight line 0 minus infinity plus infinity. So here they have given 0 to this side, so it is going to consider as what here, minus infinity to 0, and the resultant will be what here, 0.5. Similarly z greater than equal to 0 but less than equal to infinity, again this is the right hand side, again it is 0.5. This complete is 1, but 0 to minus infinity is 0.5, 0 to plus infinity is also 0.5, 0.5 plus 0.5 will get complete area of the given bell shaped normal curve. So again these two are very important. So p of z strictly less than z1. Z1 is nothing but the area what they will say. I will take one of the illustrative example based on these two, so it will be more clear. So it is, if it is less than z1, always we have to consider what here, 0.5 plus phi of z1, and p of z greater than z2 means what happens here, 0.5 minus of phi of z2. These two are most important to simplify the example. Now we'll see one of the illustrative examples so that we can understand this concept. Now illustration, to find the area under the standard normal curve z is equal to 0 and 1.55. so this is what here, z is equal to 0. So we have two results here, z is equal to 0 and z is equal to I will consider as what here, it is 1.55. So z is equal to 0 means this is a center curve, so I will draw a curve here, normal curve, which is bell shape. Okay, so z is equal to 0 means exactly center, and we know that this is the area 0.5, this is 0.5, but one more value they have given, z is equal to 1.55. so I will write somewhere, it is here, this 1.55 will be here. So you draw a vertical line and shade this. So this is the area from z is equal to 0 to z is equal to what here, 1.55. so this positive side we need to shade like that. Then this is nothing but area of phi of 1.5. we can see the table, or from the calculator we can get the what is the area, how much area means, but this area we need to apply integration theoretically, and where this given phi of z will be lying between the integral 0 to 1.55. so but here will not go theoretically, so we'll go by the standard normal, by using the standard normal variate, and with the help of the table value we have the normal distribution table, or else we can use the calculator to get the area and we can get the answer of this. Similarly, area of the standard normal curve between z is equal to 0.86 and z is equal to 0. I will draw a curve first. So a normal distribution curve. Fine. So once we draw, so z is equal to 0, it will come exactly here. So z is equal to, this is the point, z is equal to 0, and next point minus means is left side. So somewhere I can put here that this is minus 0.86. just we need to imagine, draw a perpendicular that is vertical line and shade it. So this is the area from 0 to minus 0.86. okay. So similarly, area of the standard normal curve between z is equal to minus 0.44 and z is equal to, so first draw the curve is like that. So z is equal to, so minus 0.44 means I will write here, this is minus 0.44, and z is equal to 1 point, so I will draw somewhere here, it is 1.76, so 2. So this complete area we need to calculate. So this is a shaded part. So the function phi of z is lying between minus 0.44 to 1.76. Similarly, area of the standard normal curve between z is equal to 0.57 to z is equal to 2.49. So the curve is like that. Again, draw it. So so here both are positive. So I will take here 0.57 somewhere here, and 2 point I will take here. This is the what here, 2.49. Draw the lines. So shade this area. So this area is nothing but from 0.57 to 2.49. So like that, this is just illustration. So how to get the area. So here what I want to conclude here, so this is nothing but, so while writing, so with this example I want to say here area. So to find the complete area, so here for this curve I want to just show how to find the area. So required area is equal to area between z is equal to 0 to z. So this is completely right hand side. So how to get this area? So we need to calculate, so which is nothing but, so to get this unshaded part, what we have, this area we need to find. To find this we need to subtract what here, phi of 2.49 minus phi of 0.57. So we need to find. So how to find this area? So take the calculator here as, so shift make stat mode 3, okay, and put AC button, it will vanish. So you can see that it is in stat option. So once we get this stat mode, then shift, use what here, shift, and above 1 we have stat, you press 1. So you will find this type, data, sum, variance, and so distribution, we are working distribution, press 5. So here, so instead of q, for q you consider as 5. So here this is nothing but the value of finding the normal value. So option 2 you will find here, it is written as look like q. So q you consider as a normal distribution table, q of any value. So option 2, you will find q of 2.49, you press 2.49 equal to, so what we getting here, 0.49361, that is 0.49361 minus, then again you go back, delete it, phi of 0.57 equal to sign. So we'll get the answer as 0.21566. You subtract it both, so we'll get the answer as on equivalent, it is 0.2779. So therefore it is the answer of P of x z greater than equal to 0.57 and less than equal to 2.49 is nothing but 0.2779. So area of this greater than equal to 0.57 and less than equal to what here, 2.49. So this area is nothing but 0.2779. So in this way we need to calculate. So like that we'll see the actual problems how to solve in this normal distribution. Okay, thank you.